For homework tonight, we're going to be looking at how to solve a system of equations with substitution. We're going to go through some of the directed notes that are on your handout, and then tomorrow during class you'll have a chance to practice the other problems. So again, please save the other problems for tomorrow in class so that you can work through them with your group and get feedback. So we're going to start with example 1. And you'll notice in this first section of guided notes, we're talking about checking if each ordered pair is a solution to a system. And if the pair is not a solution, we're going to explain why not. So for the first part here, we've been given a point, 3, -4, and we're going to go ahead and plug in that point into each equation. So in this case, I'm going to say -4 equals 2 times 3 minus 10. So I have -4 equals 6 minus 10, -4 equals -4. So I can tell that that point does work for the first equation here, and now I'm going to check and see that it works in the second. So now 3 times the y coordinate, -4, equals 15 minus 9 times the x coordinate, 3. That gives me -12 on this side, and then 15 minus 27. And so I get -12 equals -12. So I will consider this to be a solution because it works for both equations. The next step, I've been given a different point here. So 2, -6. Again, I'm going to plug that into my equation. So -6 equals 2 times 2 minus 10. So I have -6 equals 4 minus 10, -6 equals -6. So far this looks encouraging, and then I'm going to go ahead again and plug this point into the other equation. So I have 3 times -6 equals 15 minus 9 times 2. -18 equals 15 minus 18. I have -18 equals -3. So this is not equal, so that tells me that this point is not a solution to the system. So I'm going to say it's not a solution because it only works in one of the equations, not both. We're going to move on to example 3 now, where it talks about how to solve an equation when there are variables on both sides. You already have some experience with this, but just to kind of remind you, you need to make sure that your terms are combined if they're like terms. So in this case, I'm going to subtract 2x here and subtract 2x from the other side so that I can get my x terms on one side. So 1 equals 3x minus 9. Now I'm going to add 9 to each side. So again, I'll have that variable by itself. So 10 equals 3x. And now I'm going to go ahead and divide by 3 so I can solve for x specifically. So I'm going to end up with x equals 10/3, or 3 1/3 would also be an okay answer to give. And now we have another similar example. This time you'll notice that I need to use the distributive property. So I'm going to have 7 times x is 7x, and then 7 times -1, or you can think of it as minus 7 times 1, plus 2, equals 3x plus 7. And so now I need to combine my like terms. So I'm going to subtract 3x from each side. That'll give me 4x. I can go ahead and combine the -7 plus 2, which would give me -5 or -5, equals 7. I'm going to add 5 to each side. So I have 4x equals 12. Divide by 4, and I have x equals 3. In the next part of our notes, we're going to talk about how you solve an equation for a variable. And so, for example, here we're going to solve for x. You might notice that this looks like standard form. So it takes a little bit of work to go ahead and isolate x by itself. So we're going to use an undoing table. So looking at x, we can see that we first multiply by 3. Then we add 6y. So we're going to go ahead and undo that. So we will subtract 6y. So I'm going to have 12 minus 6y. And then we're going to do the opposite of multiplying by 3, so divide by 3. So you can imagine 12 divided by 3 would be 4, minus 6 divided by 3 would be 2. So I have 4 minus 2y. And so now I'm being given a different problem here now in example 6 and asked to solve for y. So now I'm going to go ahead. You'll notice we're using two different methods, right? The first one, example 5, had an undoing table. This one in example 6 is simply solving with the balancing method that we know. So we're going to subtract 50x from each side to start getting y by itself. So I have negative 10y equals 30 minus 50x. And now I'm going to divide both terms on the other side by negative 10. So I get y equals negative 3 plus 5x, because that negative divided by a negative makes a positive. So we're now moving on to example 7. So if both equations are already solved for the same variable, then all you're going to need to do is set the equations equal to each other. So you'll notice here we have that y equals 2x minus 10, and over here we have that y equals 5 minus 3x. So I'm going to go ahead and simply set the equations equal to each other. So I can plug in this equation here for y over here. And so when I rewrite this equation, I have 2x minus 10 equals 5 minus 3x. And you'll notice this looks similar to another equation we just did before, where we just had variables on both sides, but we were able to solve for the variable. So we're going to go ahead and combine like terms. So I'm going to add 3x to both sides. I now have 5x minus 10 equals 5. I'm going to add 10 to both sides. 5x equals 15. And now divide by 5. So x is equal to 3. So now I'm partially done. However, you'll notice I solved for the x value, but I still don't know what y is. And so this is where I solved for y by substituting my answer for x into the original equations. And you'll note that I'm going to check that x value in both equations to make sure it works. So y equals 2 times 3 minus 10. So again, I'm taking that 3 from right up here where x equals 3. So I have 6 minus 10. So I get y equals negative 4. I'm going to check that with the other equation. So y equals 5 minus 3 times 3. Y equals 5 minus 9. So y equals negative 4. So since I got negative 4 on both equations, that tells me that this is a solution to the system of equations. And so what I'm actually going to say is that the solution overall is going to be a point, an x-coordinate and a y-coordinate, in this case 3, negative 4. So that is my point that's a solution to this system of equations. In example 8, we're now going to try substituting one equation into the other to solve for x. So you'll notice this first equation starts with y equals 5x minus 10. The other equation doesn't start with y equals. The y is kind of embedded within the equation. So you see 2y minus 3x equals 8. So I'm actually going to take this whole component right here, 5x minus 10, and substitute it in for y right here. So now my equation will look like this. 2 times 5x minus 10 minus 3x equals 8. So again, I'm hoping you're noticing I'm taking this piece here and substituting it in for y. So now I'm going to go ahead and distribute the 2. So I'll have 10x minus 20 minus 3x equals 8. So now I need to combine some like terms. So 10x minus 3x would give me 7x minus 20 is 8. I'm going to add 20 to each side. So 7x equals 28. And now I'm going to divide by 7, which gives me x equals 4. So I'm not quite done yet. I need to go ahead and solve for y. So I'm going to again substitute my answer for x into the original equations. So down here, y equals 5 times 4 minus 10, y equals 20 minus 10, and y ultimately equals 10. I'm checking to make sure that that's also true in the other equation, though, before I decide that that's my correct solution to the system of equations. So now, 2 times y, I don't know y yet, minus 3 times 4 equals 8. 2y minus 12 equals 8. And now I'm going to add 12 to each side. 2y is going to equal 20. Dividing by 2, y is going to equal 10. So now I can feel confident that y is the correct value. And that means that overall, my solution to the system of equations is the point 4, 10. Again, I'm combining that x-coordinate and the y-coordinate to know the correct solution. And finally here, we have one last problem where we're going to be solving the system of equations again, but now we are solving for one variable first. So you'll notice I'm going to take this first equation right here and actually solve it for y. So I'm going to need to rewrite it a little bit. So I'm going to subtract 15x from each side. That would give me 5x equals 5y equals 10 minus 15x. I'm going to divide both terms by 5. So y is going to equal 2 minus 3x. So now that I've rewritten that equation to solve for y, I can go ahead and plug in that value into the other equation, and that's my next step. So substitute one equation into the other and solve for x. So 2 times y, I'm going to go ahead and plug in, again, this piece I found up above for what y equals. So 2 times 2 minus 3x plus 8x equals 8. I need to distribute my 2, so 4 minus 6x plus 8x equals 8. Now I've got 4 plus 2x, so I'm going to go ahead and combine these together, equals 8. I'm going to subtract 4 from each side, and now I'm at 2x equals 4. I'm going to divide by 2 on each side, and so I have x equals 2. Again, my last step here is to plug that into each equation and make sure that I get the same y value. So 5y plus 15 times 2 equals 10. So 5y plus 30 equals 10. I'm going to subtract 30 from each side. And I've got 5y equals negative 20. Divide by 5. And I have that y equals negative 4. Again, I'm going to check that in the other equation. 2 times y plus 8 times 2 equals 8. And I have 2y plus 16 equals 8. I'm going to subtract 16 from each side. So I have 2y equals negative 8, and I'm going to divide both sides by 2. So y equals negative 8 divided by 2, which is negative 4. So I can feel confident, again, that I found the correct solution to the system of equations. However, again, I need to write that solution ultimately as a coordinate pair, and so I'm going to go ahead and write 2, negative 4 as my ultimate solution to this system of equations.